Hi everyone, my name is Kepsi and welcome to my online tutorials. In today's video, we'll be discussing Valley View University end of semester examination 2019-2020 academic year on numerical and computational method. So this will be a very interesting engagement. Come along. So as you can see, this is Valley View University School of Education end of semester 2 examination 2019-2020 academic year, and the course title is Numerical and Computational Method. The course code AMETE 354, and the lecturer was Dr. Robert Akpalu, one of my favorite lecturers, and the duration for this paper is 3 hours. So this particular paper is divided into two sections, section A and section B. In section A, which is the objective, students are supposed to answer all the 30 objective questions there for 20 marks. So as you can see, there are 20 objective questions here for 30 objective questions for 20 marks. Then the section B, which carries 60 marks, students are supposed to answer 3 questions out of possible 5 questions for 60 marks. So in this video, we'll be discussing the section B by solving all the questions in that place. That's question 1, 2, 3, 4, and 5. So this is question 1. Then we have question 2. Then question 3, question 4, then question 5. So come along as we find solution to all these questions. So question 1A say using the iteration method to show that the solution to the equation 2x minus log s base 10 is equal to 7 is s is equal to 3.789. So that's the first question. So this particular question is on finding a root for polynomial functions, and we said that when we are asked to find a root for a polynomial function, there are several methods we can use. One is bisection method of successive approximation, or the iteration method, Newton-Raphson method, regular function method, and the Arnes method. And these questions specifically say that we should use the iteration method or method of successive approximations. So what does that say? We can say that our 2x minus log x base 10 minus 7 is actually equal to 0. So we can say our f of x is equal to 2x minus log x base 10 is equal to, so that's the function f of x minus 7. So our function f of x is equal to 2x minus log x base 10 minus 7. So please do well to check out my videos on method of successive approximation or the iteration method on YouTube. So with the method of successive approximation, you make x the subject of itself. That's if we have 2x minus log x base 10 is equal to 7. We can say 2x is equal to 7 plus log x base 10. Then we divide both sides by 2. So we can say our x is equal to 7 plus log x base 10 all over 2. Now how do we find the root? We need to use the location theory to determine the interval within which the root exists. So having made x the subject of itself, we need to find the interval within which the root exists. And when we find f of 3, we'll get negative 1.477. And f of 4 will get 0.3375. You see that the two outcomes produce different signs. Then we can say that a root exists within the interval 3, 4 close. And we can easily get the x naught. So our x naught is the halving of those intervals. That's 3 plus 4 divided by 2. 3 plus 4 is 7 divided by 2. That will be 3.5. So with the method of successive approximation, we are going to substitute the x naught here in this to get our x1. So that's it. So we said our x1 will be equal to, that's the first iteration, will be equal to 7 plus log 3.5 base 10 all over 2. And that will give us 3.7720. So that's our first iteration. So our second iteration will be the substituting of 3.7720 into our x. So we can say our x2 will be equal to 7 plus log 3.7720 base 10 all over 2. And that will give us 3.7788. So since the question did not indicate the number of iterations, when we reach the fourth iteration, or we find that value, the root, which they ask us to find, we can stop. So our x3 will be the substituting of x2 into x. So it says 7 plus log 3.7788 base 10 all over 2. And that will give us 3.7887. Fourth iteration, x4 will be equal to 7 plus log, that's the substitution of this into a place of x. So 7 plus log 3.7887 base 10 all over 2. And that will give us 3.789 as required. So we can say that one root of this equation, that's 2x minus log 10x, log x base 10 is equal to 7. X is actually equal to the 3.789 as required. I hope you get that. So this is the A aspect of the question. We go to the B. So the B aspect of the question says that we should find an iterative formula for finding the value of 1 over n, where n is a real number, using the Newton's iteration method. Then having gotten that, we should evaluate 1 over 26 correctly to 4 decimal places. So this particular question is on Newton-Raphson method to find at least one root for complex polynomial functions. So in that case, they say we should find an iterative formula for evaluating 1 over n, where n is a real number. So we can say we should let x to be equal to 1 over the n. What next? We'll multiply both sides by n, so we'll get xn is equal to 1. Now we'll make x the subject now. So I'll get n to be equal to 1 out of x. So I can say 1 over x minus n is equal to 0. So our f of x is now 1 over x minus n. And remember, in Newton's iterative formula, we say our xn is equal to x minus f of x over f prime of x. Please do well to check out my videos on how to find a root to a complex polynomial function using Newton-Raphson method. So having known this, we know our f of x to be 1 over x minus n. So we need to find f prime of x. That's the differential of this function with respect to x. So we are going to differentiate this function now to get our f prime of x. So we say our f of x, this can be written as x exponent negative 1 minus n. Remember, n is constant. So we can say our f prime of x is equal to, when we differentiate this, we'll drop the negative, we'll get negative x, subtract 1, we'll get negative 2. Then when we differentiate a constant, that will be 0. We can repolish this to be negative 1 all over x squared. So that's our f prime of x. Now we substitute into this. So we can say the Newton iterative formula x subscript n will be equal to x minus, what is our f of x? F of x is 1 over x minus n, and f prime of x is negative 1 over x squared. I hope you get that. So we can get our xn to be equal to x. This negative will affect that negative, we say that become plus. Then we solve this. Remember, this is over 1. So the LCM there will be x. X divided by x will be 1 times 1 will be 1. Then 1, x divided by 1 will be x times this will be nx. Then all this, only this over 1 over x squared. So we can repolish this to be xn to be equal to x plus 1 minus nx, then 1 minus nx all over x, then times x squared all over 1. That's using the reciprocal, reciprocate. So we say our xn will be equal to x plus 1 minus nx. Remember, this x will divide 1 of that x. So we'll get x plus 1 minus nx x. I hope you get that. So our xn will be equal to x plus, this times this will give us x, then minus nx squared. I hope you get that. So this and this will give us 2x minus nx squared. So we can factor out our x, so get x out and 2 minus nx. This becomes a Newton iterative formula for evaluating 1 over n. Now they say we should use that to find the value of 1 over 26. So if you find 1 over 26, it will be irrational or it will be terminating decimal. So we need to find a number that is close to 1 over 26 that is rational. So a number close to that becomes our x naught. Then we can substitute. So we can say a number that is rational that is close to 1 over 26 is actually 1 over 25. And that will be 0.04. So we can therefore say that our x naught is actually 0.04. So we let our x naught to be equal to that. And if we are evaluating 1 over 26, remember we use Newton iterative formula, or we express this 1 over n in a Newton iterative formula. Then we can say our n is 26. So our n there is 26. So we now substitute our x equal to 0.04 and n as 26 into our iterative formula to evaluate 1 over 26. So our first iteration x1 will be equal to, remember our x will be 0.04, then 2 minus 26 times 0.04. I hope you get that. So our x1 will be 0.04, then 2 minus 26 times 0.04 will be 1.04. So our x1 will be 0.04, 2 minus 1.04 will be 0.96, and 0.04 times 0.96 will give us 0.0384. That becomes our first iteration. So our second iteration, x2, will be equal to, so now our x2 will get x2 by substituting x1 in place of x. So we have 0.0382 times 2 minus n is still 26 times 0.0384. Please, it's 84. So we can say our x2 is equal to 0.0384 times 2 minus 26 times 0.0384 will give us 0.9984. And we subtract that from 2, 0.0384. This is close to 1. So we are going to get 1.0016. Having multiplied that, our x2 will be equal to 0.03846. So if you point 1 over 26 on the calculator, you are going to get 0.03846. So they say close to 4 decimal places. So we'll say this will be our x2, our 1 over 26 is actually equal to 0.0385. I hope you get that. So if you punch 1 over 26 on the calculator, you will get a number close to that, 0.0385. So the C aspect of the question 1 says, what do you understand by the following terms? I, accuracy, II, precision, and III, absolute error. So that's what we'll be explaining next. So these terms are terms that are associated with measurement and errors. So please do well to check out my videos on measurement and errors on YouTube. So when we talk of accuracy, accuracy refers to how close a measured value agrees with an actual value. So we said that when we have a line and you measure that line, and maybe the length of the line is 6 centimeters, and you measure and you have 5.9 centimeters, you have been close. So since you are close, we say you are accurate. So accurate refers to how close a measured value agrees with the actual value. Then precision is the condition or the fact of being exact or being accurate. So when you are exact, maybe you measure the length of a line and you have 6, and the length of that line is actually 6, then we say you are precise and being exact. So that's it. Then absolute error is the absolute difference between the actual value and the measured value. So we say if you measure the length of a line and you have 5.9 centimeters and the actual length of the line is 6 centimeters, the difference between the 5.9 centimeters and the 6 centimeters is actually the absolute error. Remember, we said the absolute difference. So if you haven't got a negative value, it will still be positive. So absolute error is the actual difference between the absolute difference between the actual value and the measured value. So this was all about the question 1. We jump straight to the question 2. So our question 2a says that we should find the positive root of s exponent 4 minus s equal to 10 correctly to 3 decimal places using Newton-Raphson's method. So this particular question is on finding at least one root for complex polynomial functions using Newton-Raphson method. And remember, when we are finding root to complex polynomial function using Newton-Raphson method, we need to find the iterative formula. So this can be rewritten as s exponent 4 minus x minus 10 equal to 0. So we can say our f of x is equal to x exponent 4 minus x minus 10 equal to 0. Then we find our f prime of x. That's we differentiate this function with respect to x. So this will give us 4 exponent 3 minus 1. I hope you get that. And remember the Newton iterative formula, xn is giving us x minus f of x over f prime of x. So our xn is equal to x minus, our f of x, remember, is this function, s exponent 4 minus x minus 10. Then our f prime of x is 4 exponent 3 minus 1. So what we do, we find the LCM here. So our xn, the LCM, remember, will be 4x exponent 3 minus 1. This s is over 1 divides that. It will be 4 exponent 3 minus 1. It will multiply the x. So x bracket 4 exponent 3 minus 1 minus s exponent 4 minus x minus 10. So we can expand bracket. We say our xn is equal to, this time this will give us 4 exponent 4, then minus x, and this will be minus s exponent 4, and plus x plus 10, all over 4x exponent 3 minus 1. So our xn will be equal to 4 exponent 4 minus s exponent 4 will give us 3s exponent 4, then minus s plus s, that will be 0. So we'll be left with plus 10 there, all over 4s exponent 3 minus 1. So having gotten the iterative formula, we need to find the interval within which at least a root exists. Then, having gotten those intervals, we can find our x naught and we substitute into this to find our first iteration. So if we find f of 1, that's substituting 1 into this, we get negative 10, and f of 2, that's substituting 2 into this, we get 4. Then we can say that a root exists within the interval 1, 2, close. Then our x naught will be the halving of this interval, that's 1 plus 2 all over 2. And this will give us 3 over 2, and that will be 1.5. So having now our x naught, we substitute into this to get our x1. So our x1 will be equal to 3 times 1.5 exponent 4 plus 10 all over 4 1.5 exponent 3 minus 1. If we solve that very well, we'll get 2.015. So that will become our x1. So now we find our x2. x2 will be substituting x1 in place of x. So we say our x2 will be 3 times 2.015 exponent 4 plus 10 all over 4 bracket 2.015 exponent 3 minus 1. If we solve that very well, we'll get our x2 to be 1.8741. Then we find our x3. Our x3 will be the substituting x2 in place of x. So we say that will be 3 bracket 1.8741 exponent 4 plus 10 all over 4 bracket 1.8741 exponent 3 minus 1. If we solve that very well, we'll get our x3 to be 1.8559. Now we need to find our x4, the fourth iteration. That will be substituting this in place of x. So we'll get 3 times 1.8559 exponent 4 plus 10 all over 4 bracket 1.8559 exponent 3 minus 1, and that will give us 1.85558. So we can therefore say that a positive root to x exponent 4 minus x equal to 10 is 1.856. That's correct to 3 decimal places using the Newton-Raphson method. I hope you get this. We'll go to the B aspect of the question 2. So the B aspect of the question 2 says that use regular forcing method to show that the positive root of s exponent 3 minus 3s minus 5 equal to 0 is 2.2506. So this question actually is on using the regular forcing method to find at least one root for complex polynomial function. Please do well to check out my videos on using regular forcing method to find at least one root for complex polynomial functions on YouTube. So our f of x is therefore x exponent 3 minus 3x minus 5. So with the regular forcing method, our x subscript n is equal to a f of b minus b f of a all over f of b minus f of a, if you will correct very well. So how do we find a and b and f of a and f of b? That's the we can use the location theory to find that. So if we find f of 2, we'll get negative 3, and f of 3 we'll get 13. So we can say that our a is equal to 2, our f of a is equal to negative 3, our b is 3, and our f of b is equal to 30. Now we substitute into this to get our first iteration. So our first iteration, x1, will be equal to our a, which is 2, our f of b is 13, then minus our b, remember, is 3, and f of a is negative 3, all over f of b, which is 13, then minus f of a, which is negative 3. So this will give us 2 times 13, that will be 26. Then negative 3 times negative 3, that will be plus 9. Then this will be 13 plus 3. So 26 plus 9, that will be 35 over 16. And 35 divided by 16 will give us 2.1875. So what next? We need to find f of 2.1875 to see which of these intervals will it replace. So we find our f of 2.1875. That's substituting 2.1875 into f of x. We substitute in place of x there. So when we find f of 2.1875, we get negative 1.0950. So that means this will replace the one that initially produced a negative outcome. That's the f of a. So we can say our a now is 2.1875, and our f of a will be negative 1.0950. Our b will be still 3, and our f of b will be 13. Then we'll find our second iteration. So our second iteration, x2, will be equal to a, which is 2.1875, f of b, which is 13, then minus b, which is 3, times f of a, which is negative 1.0950, all over f of b, which is 13, then minus f of a, which is negative 1.0950. So x2, therefore, we got 1 multiply 2.1875 by 13. We get 28.4375, and this times this will give us plus 3.285. All over 13. Remember, this place is negative, so 13 plus 1.0950. Our x2 therefore will be equal to 28.4375 plus 3.285 will give us 31.7225. Then 13 plus 1.0950 will give us 14.0950. And that will give us 2.2506 as we are asked to solve. Then we can conclude that a positive root to x exponent 3 minus 3x minus 5 is 2.2506 as required. I hope you get that. This is very simple. We go to the C aspect of the question 2. So the C aspect of the question 2 says we should determine the equation of the function that is represented by the following table of values, where the x values ranges from negative 1, 1, 3, 5, and 7, and the y values are 1, 9, 1, negative 23, and negative 63. So this particular question is on using finite difference to find a polynomial function that connects two sets of values. So the first thing we need to do is to construct a difference table. Please do well to check out my videos on how to construct difference table on YouTube, as well as how to find a polynomial function that connects two sets of values. So what do? We find a difference, the first difference between 9, that's 9 minus 1, that will give us 8. 1 minus 9, that will be negative 8. Negative 23 minus 1, that will be negative 24. Then negative 63 minus negative 23, that will be negative 40. So since the first difference are not the same or are not constant, we need to find the second difference. So negative 8 minus 8, that will be negative 16. Negative 24 minus negative 8, that will be negative 16. Then negative 14 minus negative 24, that will be negative 16. So having known that the second difference are all constant, then the polynomial function that connects these two sets of values is a quadratic function, is a quadratic polynomial. So we can say our y will be in the form ax squared plus bx plus c. So having known the form or the degree of the polynomial function, we need to construct another difference table using the form of the quadratic function. So having known that our y is equal to ax squared plus bx plus c, we substitute negative 1 in place of that. So when we substitute negative 1 in the place of x there, we'll get our y to be a minus, that's negative 1 squared is 1, then b times negative 1 will be negative b, then plus c. When we substitute 1, we'll get a plus b, then plus c. When we substitute 3 squared is 9, so we'll get 9a plus 3b, then plus c. When we substitute 5, we'll get 25a plus 5b, then plus c. When we substitute 7, we'll get 49a plus 7b, then plus c. Then we'll find the difference as such. So when we subtract a from a, that will be 0. Then b, this b minus negative b, that will give us 2b. Then c minus c will be 0. So we'll say this place will be 2b. Also, we subtract this from this, 9a minus a, that will give us 8a. Then 3b minus b, that will be 2b. C minus c, that will be 0. We subtract this from 25 minus 9a, that will be 16a, then plus 2b. C minus c will be 0. Then we subtract this, 49 minus 25, that will give us 24a, then 7b minus 5b, that will be 2b. C minus c will be 0. Now find the next difference. So 8a minus 2b minus 8a plus 2b minus 2b, that will give us 8a. Then this minus this will also give us 8a. This minus this will also give us 8a. So having known the forms, we just compare this table with this table. Then we can find the value of a, b, and c. So we can say that this 2b here is equal to 8. Then 8a is negative 16. You can see negative 16 throughout and 8a throughout. We equate it to get a value of a and b then c. So we can say that our 8a is equal to negative 16. We divide both sides by 8. A will be equal to negative 2. Also, 2b is equal to 8. We divide both sides by 2. Our b will be equal to 4. So, we can also say a minus b plus c is equal to this one here. So, remember our a is negative 2. So, negative 2. Our b is 4, so minus 4 plus c will be equal to 1. And negative 2 minus 4 will be negative 6 plus c is equal to 1. Our c will be equal to 1 plus 6. Our c will be equal to 7. So our a is negative 2, b is equal to 4, and c is 7. Then we can say the polynomial function that connects y to x or x to y will be negative 2x squared plus 4x then plus 7. I hope you get that. This is very simple. Now we'll go to the third question. So our question 3 is assuming that the following value of y subscript x below is a polynomial of degree 4, find the next 3 values of y subscript x. So this is the A aspect of the question 3. We'll find solution to that. So this particular question is on how to use a finite difference to find missing values So please do well to check out my videos on how to use difference table to find missing value connecting two sets of values. So we need to compare difference table. Remember they said the polynomial function is 2 degree 4. So we need to find a difference between these. So negative 1 minus 1, that will be negative 2. 1 minus negative 1 will be 2. Negative 1 minus 1, that will be negative 2. 1 minus negative 1, that will be 2. So if this is our y1, this will be y1, y2, y3, y4. This will be y5, then y6, then y7. Then we can set the difference here, y5 minus 1. Then this will be y6 minus y5. Then this will be y7 minus y6. Okay, we'll find the second difference. 2 minus negative 2, that will be 4. Negative 2 minus 2, that will be negative 4. 2 minus negative 2, that will be 4. Then y5 minus 1 minus 2, that will be y5 minus 3. Then y6 minus y5. So we have y6 minus y5. Then minus y5 minus 1. So this will be y6 minus y5. Then minus y5 plus 1. So this will be y6 minus 2y5 plus 1. So we can say the difference here will be y6 minus 2y5 then plus 1. Then this will be y7 minus y6 then minus y6 minus y5. So we have y7 minus y6 minus y6 then plus y5. So that will be y7 minus 2y6 then plus y5. So we'll say the difference here will be y7 minus 2y6 then plus y5. Now we'll find the third difference. So we'll find the third difference. Minus 4 minus 4, that will be minus 8. Then 4 minus negative 4, that will be 8. So y5 minus 3 minus 4, that will be y5 minus 7. Then this y6 minus 2y5 plus 1, then minus y5 minus 3. So that will be y6 minus 2y5 plus 1 minus y5 plus 3. So that will be y6 minus 3y5 then plus 4. We'll say the difference here will be y6 minus 3y5 then plus 4. Now, what will be the difference here? That will be y7 minus 2y6 plus y5, then minus y6 minus 2y5 then plus 1. When we expand that bracket, we get y7 minus 2y6 plus y5 minus y6 plus 2y5 then minus 1. This will give us y7 minus 3y6, this and this, then plus 3y5 then minus 1. So that will be y7 minus 3y6 plus 3y5 then minus 1. I hope you get that. Now we'll find the fourth difference. So we'll find the fourth difference. 8 minus negative 8, that will be 16. y5 minus 7 minus 8, that will be y5 minus 15. Then this will be y6 minus 3y5 plus 4 minus y5 minus 7. So that will be y6 minus 3y5 plus 4 minus y5 plus 7. So that will be y6 minus 4y5. Then 4 plus 7, that will be 11. So this will be y6 minus 4y5 then plus 11. Now we'll find the difference between this and this. So that will be y7 minus 3y6 plus 3y5 minus 1, then minus y6 minus 3y5 then plus 4. So that will be y7 minus 3y6 plus 3y5 minus 1 minus y6 plus 3y5 then minus 4. So that will be y7 minus 3y6 minus y6 will be minus 4y6. Then 3y5 plus 3y5 will be 6y5. Then minus 1, that will be minus 5. So this will be y7 minus 4y6 plus 6y5, then minus 5. So if this polynomial function is said to be degree 4, that means all the constants or all the values here will be the same. Then we can say 6 is equal to this value. 16 is equal to, so we can say our y5 minus 15 will be equal to 16. Then y5 will be equal to 16 plus 15. Our y5 will be equal to 31. I hope you get that. Also, this will be equal to that. So we can say our y6 minus 4y5 plus 11 will be equal to 16 as well. So our y6 minus 4, our y5, remember, is 31. So 31 plus 11 will be equal to 16. So our y6 will be 4 times 31, that will be 4. That will be y6 minus 124 plus 11 is equal to 16. So when we solve it out, that 16 minus 113 is equal to 16. So our y6 will be equal to 16 plus 113. Our y6 will be equal to 129. Now we find our y7. Remember, this will also be equal to 16. So you can say y7 minus 4y6 plus 6y5 minus 5 is also 16. So we substitute to get our y7. So we can say y7 minus 4. Remember, our y6 is 129 plus 6. Our y5 is 31, then minus 5 equal to 16. So we get y7. 4 times 129, that will give us minus 56. We minus 516. Then 6 times 31 will be 186. Minus 5 will be equal to 16. So our y7 minus 516 plus 186. Then minus 5 will give us minus 335. So minus 335 equal to 16. Our y7 will be equal to 16 plus 335. Then our y7 can be said to be equal to 351. So our y7 will be equal to 351. So having gotten that, we can say that those spaces which we are asked to fill, this will be 31, this will be 129, and this will be 351. I hope you get this. Now we'll go to the B aspect of the question 3. So the B aspect of the question 3 says that we should find a cubic polynomial which take the following set of values, that's 0, 1, 1, 2, 2, 1, and 3, 10, using Gregory Newton's forward interpolation formula. So this particular question is on how to use Gregory Newton's forward difference interpolation formula to find the polynomial function that connect two sets of values. Please check out my videos on how to apply Gregory Newton's forward difference interpolation formula to find a polynomial function that connect two sets of values on YouTube. So the first thing we need to do is to construct difference table. And remember, the question is saying that the polynomial function that connect these two sets of values is of degree 3. Then we have to construct a difference table up to the third difference. So we can say that the x values are 0, 1, 2, and 3. And the y values are 1, 2, 1, and 10. So we find the first difference between the y values. Then 2 minus 1 will be 1. 1 minus 2 will be negative 1. And 10 minus 1, that will be 9. So we find the second difference again. Negative 1 minus 1 will be negative 2. 9 minus negative 1, that will be 10. Then 10 minus negative 2, that will give us 12. So remember, the Gregory Newton's forward difference formula is given like this. Please, if you want to know how these formulas came about, look for my name, Tete Jacobs Rashid, on YouTube and find out how Gregory Newton's forward difference and backward difference formula came about. So we say our yn is equal to y naught plus n delta y naught plus n minus 1 all over 2 factorial delta square y naught plus n minus 1 n minus 2 all over 3 factorial delta cube y naught. And what are the value of this y naught, delta y naught, delta cube y naught, and delta square y naught and delta cube y naught? That's these values using the forward difference. So we can say our y naught is actually 1. Our delta y naught is also 1. Delta square y naught is 2. And delta cube y naught is 12. So we need to find our n. And remember, our n is giving us x minus x naught all over h, where h is the interval of difference. So we can say this is x minus, our x naught here is 0. That's the first value of x. So we can say 0. And what are the difference between the x values? You can say the difference between them is 1, 1. Then we can say our h is 1. Then we have x minus 0 is x over 1. X minus 1 is 1. Is x. Then we can say our n is x. Now we substitute into this formula. So we can say our y subscript x will be equal to y naught, which is 1, plus our n is x. Delta y naught is 1. Then plus n is x, x minus 1, all over 2 factorial, and our delta square y naught is negative 2. Then plus x, x minus 1, x minus 2, all over 3 factorial, and our delta cube y naught is 12. So what we have, we'll have our xn, y subscript x will be equal to 1, plus this times this will be x, then this times this will get x squared minus x, 2 factorial is 2, times negative 2, then plus this times this will give us x squared minus x, then times x minus 2, all over 3 factorial is 6, then times 12. So when we polish this further, we'll get y subscript x is equal to 1 plus x. These two can divide that to get negative 1. So we'll get minus 1 times x squared minus x, then plus 4 divided by 6 will be 2, so we'll get 2 bracket. Then x times x squared will give us x cubed. X times this will be minus x squared. Negative 2 times this will be minus 2x squared. And negative 2 times this will be plus 2x. So we expand our y subscript x will be equal to 1 plus x minus x squared minus x. Then we have plus 2x cubed minus x squared minus 2x squared will be minus 3x squared, then plus 2x. So when we expand further, we get 1 plus x minus x squared plus x, then plus 2x cubed minus 6, this time this will be minus 6x squared, then plus 4x. So when we group like terms by rearranging this in the descending power of x, then we can say our y subscript x will be 2x cubed, then we have minus x squared minus 6x squared, then plus x plus 4x, then plus 1. So our y subscript x will be equal to 2x cubed minus x squared minus 6x squared will be minus 7x squared, x plus x, 2x plus 4x, that will be 6x, then plus 1. Then we can say this is the polynomial function connecting those two sets of values. I hope you get that. So our question 4a says we should derive the Newton algorithm for finding the p-th root of the number n, and hence we should find the cube root of 17. So this particular question is also on how to the application of Newton-Raphson method in finding at least one root for complex polynomials. So they say we should find the iterative formula or Newton algorithm for evaluating the p-th root of n. where n is the number. So we can say we should let x to be equal to the p root of n. Then we can also say that our x is equal to n exponent 1 over p. I hope you get that. If the p root of n is the same as n exponent 1 over p. So we can find the p root of both sides. Then we can say s exponent p is equal to this p, will cancel this p. N exponent 1 is to n. Then we can say this is s exponent p minus n is equal to 0. So our f of x can be equal to s exponent p minus n. What next? Remember the Newton's algorithm is given as s exponent s subscript n is equal to x minus f of x over f prime of x. So having known that f of x is this, we find f prime of x. And f prime of x is just the differential of this function. So when we differentiate this function, that's finding f prime of x will be equal to, remember, we use simple differentiation rule. So we'll drop the exponent p and we subtract 1 from it. I hope you know that. This is a constant. When we differentiate it, it will be 0. Then we can say the algorithm s subscript n will be equal to x minus. Remember, our f of x will be s exponent p minus n over f prime of f, which is p s exponent p minus 1. So what do? We solve this further. Remember, the LCM here will be p s exponent p minus 1. If this goes here, this is over 1. If this goes here, it will be that. So we'll say x times p s exponent p minus 1. Then minus s exponent p minus n. So we polish further. This will be, so s is multiplying this. Remember, this s is exponent 1. And indices, when we are multiplying two indices with the same base, we repeat the base and just add the exponent. So minus p minus 1 plus 1 will be p. So we say this will be p s exponent p. Then this will be minus s exponent p. Then minus plus n all over p s exponent p minus 1. So what is common here? You can see s exponent p is common. And you can say the Newton algorithm will be s exponent p bracket p minus 1 plus n all over p s exponent p minus 1. And remember, they say we should use this to evaluate or find the cube root of 17. So having gotten the Newton algorithm, we are asked to evaluate the cube root of 17. And remember, this algorithm is developed from the p root of 17, the p root of n. Then when we compare, we can say our p is 3 and our n is 17. So we can substitute that. You can say s exponent n, x subscript n will be equal to x exponent 3. Remember, p is 3, then times 3 minus 1 plus 17 all over p is 3. So 3 s exponent 3 minus 1. Don't polish this further. We'll get 3 minus 1 is 2. 2 times this will be 2x exponent 3 plus 17 all over 3s squared. So I haven't gotten this. Now we need to evaluate the cube root of 17 by finding the value of the x naught from the interval, or using the location theory to find the interval. Then we substitute to find the cube root of 17. Now we need to get that x naught, but before we can get that, remember we are evaluating the cube root of 17. Before we can get that, let's find 2 cube. 2 cube will give us 8, and 3 cube will give us 27. That means 17 is found between the two perfect cube roots, which is 8 and 27. The two perfect cubes, that's 8 and 27. So 17 is found among them. Then we can say that the cube root of 17 exists within this interval. I hope you get that. So that can make us get our x naught. So we can say our x naught will be equal to 2 plus 3 all over 2. 2 plus 3, remember, is 5. 5 divided by 2 will be equal to 2.5. So we can find our first iteration, x1. That will be equal to substituting 2.5 into this. So we get 2 bracket 2.5 exponent 3 plus 17 over 3 times 2.5 squared. When we solve this very well, we'll get 2.5733. 2.5733. Now we need to find the second iteration too. Our x2 will be equal to the substituting of this in place of x now. So 2 bracket 2.5733 cube plus 17 over 3 times 2.5733 square. When we do that very well, we'll get 2.5713. 2.5713. And when we try to find the cube root of 17, when we find the cube root of 17, we'll be getting 2.5713, correct to 4 decimal places. Then we can conclude that the cube root of 17 is actually 2.5713 using the Newton algorithm of finding the PV root of A. I hope you get that. Now we'll go to the B aspect of the question 4. So the B aspect of the question 4 says we should find a polynomial which take the following values and hence compute y subscript x if x is equal to 2 and if x is equal to 12. So this particular question was on how to use difference table to find the polynomial function that connect two set of values. Please do well to check out my video on YouTube by searching for my name, Kepsi Richard. Subscribe to my YouTube channel, like and share my videos. So these are the x values and their corresponding y values. So we need to find the first difference. The first 40 minus 3 will be 11, 19 minus 14 is 5, 21 minus 19 will be 2, 23 minus 21 will be 2, 28 minus 23, that will be 5. The second difference, that's 5 minus 11 will be negative 6, 2 minus 5 will be negative 3, 2 minus 2 is 0, 5 minus 2 will be 3. Then we'll go further to find the third difference. We find the same constant or where the values will be the same. Negative 6 minus negative 3 minus negative 6 will be 3. 0 minus negative 3 will be 3. 3 minus 0 will be 3. So since they are all the same now we know that the polynomial function is to the third degree. So we can say our y will be equal to ax cubed plus bx squared plus cx plus d. That's how the polynomial function will look like. So we need to construct another difference table by substituting the x values into this polynomial function to get the y. So when we substitute 1, we'll get this. We substitute 3, we'll get 7a plus 9b plus 3c plus d. Remember, y is actually equal to ax cubed plus bx squared plus cx plus d. So on substitute 5 into 3 into this, we'll get that. 5 into this, we'll get this. 7 into that, we are going to get this. 9 into this, we'll get that. And 11 into that, we'll get 1331a plus 121b plus 11b, then plus d. Now we'll find a difference between them again. So when we subtract this from this, we get 26a plus 8b plus 2c. We subtract this from this, we'll get this. We subtract this from this, we'll get this. Subtract this from this, we'll get this. Subtract this from this, we'll get that. We'll find a second difference. When we subtract, we'll get all this. When we find a third difference, we'll get 48 throughout. Then we can say all these values here are equal to the values here. And all the values here are also equal to the values there. And all the values here are also equal to the values there. So in nutshell, we can say that 48a is equal to 3 because 48 corresponds to 3. Now we divide both sides by 48 to get our a. So here by 48, here by 48. Then our a will be equal to 1 out of 60. I hope you get that. Now we can find our b. So we can say 72a plus 8b is equal to negative 6. This is equal to this. So we now substitute a equal to 1 over 16 into this. So we can say 72 times 1 over 16 plus 8b is equal to negative 6. 72 times 1 over 16 will give us 9 over 2. So plus our 8b is equal to negative 6. 8b will be equal to negative 6 minus 9 out of 2. 8b will be equal to negative 21 over 2. When we divide both sides by 8, we'll get b to be equal to negative 21 over 60. So we can also say that 26a plus 8b plus 2c will be equal to this 11. So we substitute, we know the value of a and b, we substitute. We say 26 times a is 1 over 16 plus 8, b is negative 21 over 16, then plus 2c will be equal to 11. 26 times 1 over 16 will give us 13 over 8. Then 8 times negative 21 over 16 will give us negative 21 over 2. Then plus 2c will be equal to 11. 13 over 8 minus 21 over 2 will give us negative 71 over 8 plus 2c will be equal to 11. So our 2c will be equal to 11 plus 71 over 8. 2c will be equal to 159 out of 8. Now we can divide both sides by 2. Our c will be equal to 159 over 16. So we can also say that a plus b plus c plus d is equal to 3. So a plus b plus c plus d will be equal to 3. And what's our a? Our a is 1 over 16. Our b is negative 21 over 16. And our c is 159 over 16 plus d will be equal to 3. So when we perform the operation for this, we'll get 139 over 16, then plus d will be equal to 3. So our d will be equal to 3 minus 139 over 16. And when we do it well, we'll get negative 91 over 16. So we'll say our d is equal to negative 91 over 16. So having known the value of a, b, c, and d, we can now substitute. So we substitute our y, therefore, will be equal to our a is 1 over 16. So 1 over 16 s cubed. Then minus b is 21 over 16 x squared. And our c is 159 over 16x. And our d is minus 91 over 16. We can rewrite this as 1 over, we can rewrite this as s cubed minus 21x squared plus 159x minus 91 all over 16. Remember, they say we should find the value of y if x is 2 and if x is 12. So when we find the value of y when x is 2, we just substitute 2 here. So we get 2 cubed minus 21 times 2 square plus 159 times 2 minus 91 all over 16. When we do it well, we'll get 151 over 16. And that to decimal will be 9.4375. Y when This is when x is 2. Now when x is 12, our y will be equal to 12 cubed minus 21 times 12 squared plus 159 times 12 minus 91 all over 60. And we'll do that very well. We'll get 521 over 60. And that to decimal will be 32.5625. I hope you get that. So this is all about the question 4. We'll go to the last question, which is question 5. So the last question, which is question 5a, say we should use Simpson's rule with 5 ordinate to find an approximation to the integral spanning from 1 to 3 of 1 all over the square root of 1 plus x cubed dx. Give you your answer to 3 significant figures. So this particular question is on using Simpson's 1/3 or 3/8 rule to find to integrate or find the area under a particular curve. So we are going to use Simpson's 3/8 rule to do this. So the first thing we need to do is to find the interval of difference. That's h, and h is giving us b minus a all over n. And remember, the b is 3 and the a is 1. What about the n? The n is the number of vertices. And remember, they say with 5 ordinate. So n, therefore, the number of vertices is the number of ordinate minus 1. So we can say n is equal to 4 minus 1. So our h will be equal to b, which is 3 minus 1. So 5 minus 1 is 4. All over 4, which will be 2 over 5, and 2 over 4, and 2 over 4 is half, or 0.5. So we can say our h is equal to 0.5. Now we need to, so that means that the interval between the x values will be 0.5. So we start from 1, we'll go to 1.5, then we'll go to 2, then 2.5, then the last one will be 3. Now to get the y value, we substitute the x into this function to get the y values. So when we substitute 1 into this, we'll get this, 1.5 will get this, 2 will get that, 2.5 will get this, and 3 will get that. Now what does Simpson's 1/8 rule say? Remember, this will be our y0, our y1, our y2, y3, then this will be our yn. The Simpson's 1/8, so we have two Simpson formula, 1/3 and 1/8. And remember, we said that the 1/3 rule can only be used if the n is an even number. And remember, the n here is 4. It's an even number. Then we can use 1/3 rule. And we use 3/8 rule if the n is a multiple of 3. And remember, this is not a multiple of 3. So we cannot use the 3/8. Rather, we'll use the 1/3. So with the 1/3 rule, Simpson is saying that the integral spanning from 1 to 3 of 1 all over the square root of 1 plus x squared dx will be equal to 1 over 3h y0 plus yn plus 4 times all the values of y in odd position. That's y1 and y3. So y1 plus y3. Then plus 2, all the values of y in even position. And in this case, it's only y2, so y2. So when we substitute, this will be 1/3. Remember, our h is 0.5, so 1/3 times 0.5. Our y0 is 0.7071. Then plus our yn is 0.1889. Then plus 4. Our y1 is 0.478. Then plus our y3, which is 0.2452. So 0.2452. then plus 2 times our y2, which is 0.3333. So when we multiply 1/3 by 0.5, we'll get 1/6. Get 1/6. Then 0.7071 plus 0.1889 will give us 0.896. Then 4 times 0.478 plus 0.2452 will give us 0.7282. Then plus our 2 times 0.333 is what is given here. So now we have our 0.896, 4 times 0.2882 will give us 2.8928, and 2 times 0.333 will give us 0.6666. And we add 0.896 to 2.8928 to 0.666, we get 4.4554 times 1/6 will give us 0.7436. So correct to 3 significant figures, we can say the integral spanning from 1 to 3 of 1 all over the square root of 1 plus s cubed dx is equal to 0.743. Correct to 3 significant figures. I hope you get that. This is all about the A aspect of the question 5. Now we'll go to the B aspect of it. So the B aspect of the question 3 says we should use the Gauss-Jordan elimination to solve the linear system x plus y plus z equal to 3, 2x plus 3y plus 4z equal to 11, and 4x plus 9y plus 16z equal to 41. So this question actually is on Gauss-Jordan elimination, and Gauss-Jordan elimination simply means that we should reduce our augmented matrix to reduce row echelon form. In this case, we will not box up as in Gaussian elimination. Please do well to check out my videos on how to solve system of equations using Gauss-Jordan elimination. So first, we need to write the system of equation as an augmented matrix. So we'll just write the coefficients of them. So the coefficient here is 1, the coefficient here is 1, the coefficient here is 1. Then we'll have equal to 3. The coefficient here is 2, the coefficient here is 3, there is 4, then equal to 11. Then the coefficient here is 4, the coefficient here is 9, then 16, then equal to 41. So this is our augmented matrix. So the Gauss-Jordan is saying that we should reduce this augmented matrix to a reduced row echelon form. What is the meaning? It means that we make all the entries in this diagonal 1, we make all the entries below the leading diagonal 0, and we make all the entries above the leading diagonal 0. Then the values here becomes x. The value here will be x, the value here will be 1, and the value here will be z. So that's what we do. So first we reduce all these to 0. Then next we reduce all these to 0. Then we reduce all the entries in the leading diagonal to 1. Then we take it from there. So look at it. So the first thing is to make this 0. And how do we make this 0? When we multiply this by 2 and subtract this from this and substitute into this column, then this can be 0. So we say we should multiply 2 by R1. This becomes R1, R2, R3. Or multiply 2 by R1 and subtract our R2 from it. We should substitute that into R2. So that means our R1, our first column will not be, our first row will not be affected, as well as the third row will also not be affected, since we are substituting into the second. So when we multiply 2 by 2, 2 by 1, then we subtract 2. 2 by 1 is 2. 2 minus 2, that will be 0. So this place will be 0. Next, we multiply 2 by 1, then we subtract 3 from it. 2 by 1 will be 2. 2 minus 3 will be negative 1. The next, we multiply 2 by this 1, then we subtract 4 from it. 2 by 1 will be 2. 2 minus 4, that will be negative 2. The next one. So the next, we'll multiply 2 by this 3, then we subtract 11 from it. 2 by 3 is 6. 6 minus 11, that will be negative 5. Then we'll write it here. Our next is to reduce this also to 0. So our next step is to make this 0. And how do we make this 0? Once multiply this by 4 and subtract this 4 from it, this and substitute into this will be 0. So we say that 4 times R1 minus R3 should be substituted into R3. That means our R1 and R2 will not be affected. So we say 1, 1, 1, then 3. Our R2 will not be affected. It will be as it is, negative 5. Now we perform for this. So we say 4 times 1, then minus 4. 4 times 1 is 4, minus 4, that will be 0. And the next step will be 4 times this 1 minus 9. So 4 times 1 minus 9. 4 times 1 will be 4 minus 9. That will be negative 5. The next step will be 4 times 1, then minus 16. 4 times 1 will be 4, then minus 16. 4 minus 16, that will be negative 12. So this will be negative 12. Then our next step will be 4 times 3 minus 21. So we say 4 times 3 minus 41 rather. 4 times 3 will be 12. 12 minus 41, that will be negative 29. So this will be negative 29. Our next step is to make this also 0. So our next step is making this 0. So if you multiply this by 5, we'll get negative 5. And when we subtract negative 5 from it, we'll get 0. So we say 5 times R2 minus R3 should be substituted into R3. That means our R1 and R2 again will not be affected. So repeat them. This will be 1, 1, 1, then 3, then 0, negative 1, negative 2, negative 5. So only the R3 will be affected. So 4 times 0 minus 0. 4 times 0 is 0, minus 0 will be 0. The next step, 4 times negative 1, that's 4 times this negative 1, minus negative, so 5 is 5, 5R2 minus R3. So 5 times 0 minus 0 will be 0. Now 5 times negative 1 minus negative 5. 5 times negative 1 will be negative 5. Negative 1 minus negative 5, that will be plus 5, and that will give us 0. The next step is 5 times negative 2. 5 times negative 2 minus negative 12. 5 times negative 2, that will be negative 10. Minus negative 12 will be plus 12. Negative 10 plus 12, and that will be 2. So this will be 2. So our next will be 5 times negative 5. 5 times negative 5, then minus negative 29. 5 times negative 5, that will be negative 25, then plus 29. Negative 25 plus 29, that will be 4. So this place will be 4. Our next step is to make, so now all the entries below the leading diagonal are 0. Now we'll make all the entries above this leading diagonal also to be 0. So our next step is to make this here 0. Now if I add 2 to negative 2, this will be 0. So we say that our R2 plus R3 should be substituted into R2. This means that our R1 and R3 will not be affected. So we say 1, 1, 1, 3, then 0, 0, 2, 4. So now we add our R2 to R3 and substitute into R2. So 0 plus 0, that will be 0. 0 plus -1, that will be -1. Then -2 plus -2, that will be 0. Then -5 plus 4, that will be -1. So our next step is to make this here 0. So how do we make 0? When we multiply this by 2 and we subtract this 2 from it, it will become 0. So we say 2 times our R1 minus R3 should go into our R1. So that means our R2 and R3 will not be affected, only the R1. So 2 times our R1 minus R3. So 2 times 1, that was 2 minus 0, that will be 2. Our next step is to multiply 2 by this 1, then we subtract 0 from it. So 2 times 1 minus 0. 2 times 1 will be 2 minus 0. That will be 2 as well. Then the last one will be 2 times 1 minus 2. So 2 times 1 minus 2. 2 times 1 is 2. 2 minus 2, that will be 0. The next step will be 2 times 3, then minus 4. 2 times 3 is 6. 6 minus 4, that will be 2. So we have succeeded in making this 0, this 0. The next step is to make this also 0. So you see that when we multiply this by 2, and we will get -2. -2 plus 2, that will be 0. So we can say that our 2 times R2 plus our R1 should be substituted into our R1. So what are we getting? That means our R2 and R3 will not be affected, only the R1. So let's go. So 2 times 0 will be 0 plus 2, that will be 2. So this place will still be 2. Then the next step is 2 times -1 plus 2. 2 times -1, that will be -2. -2 plus 2, that will be 0. Then the next step will be 2 times 0, which is R2, then plus 0. 2 times 0 is 0, plus 0 will be 0. Then the next step will be 2 times -1, then plus 2. 2 times -1, that will be -2. -2 plus 2 is still 0. So now we have succeeded in making all the entries below and above the leading diagonal as 0. Now our main focus is to make the entries at the leading diagonal to be 1. Now how do we make this 1? When we divide this by 2, we get 1. So we say that half of R1 should go into R1. Then also when we multiply this by -1, we'll get 1. So we say -R2 should go into our R2. Then when we multiply this by half, we'll get 1. So we say half of R3 should be substituted into R3. So we go 2 times half will be 1, 0 times half will be 0, 0 times half will be 0, then 0 times half will also be 0. 0 times -1 will be 0, -1 times -1, that will be 1, 0 times -1, that will be 0, then -1 times 1, that will be 1. 0 times half will be 0, 0 times half will be 0, then 2 times half will be 1, 4 times half, that will be 2. So having gotten these values, this will be the x values, this will be the y, and this will be z. So we say our x is equal to 0, y is equal to 1, and z is equal to 2. I hope you understand this. Please, we'll end it here today. Remember to subscribe to my YouTube channel before you sign out. Like, share, and comment on my videos because your comment keep me going. Until we meet again, please, my name is Tete J. Richard.